Metals and non-metals. Lesson preview. Occurrence of metals. Occurrence of non-metals and metalloids. Physical properties of metals. Chemical properties of metals and non-metals. Uses of some metals. Uses of some common non-metals and metalloids. We use a number of articles made of various kinds of metals and non-metals in our daily lives. Some of the commonly used metals are iron, aluminium, copper, etc. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Some examples of non-metals are hydrogen, sulfur, carbon, phosphorus, chlorine, bromine, iodine, oxygen, etc. Besides metals and non-metals, there are certain other elements which have some properties of metals and some properties of non-metals. They are called metalloids. Some common metalloids are silicon, arsenic, antimony, and germanium. Occurrence of metals. Metals mostly occur in nature in combined states as minerals. Nearly all rocks contain some metallic minerals. Often the amount of metal present in rocks is so little that mining and extracting metal from them is too expensive and thus not a viable process. However, if the amount of metal is more, it is profitable to mine the rocks and extract metal. High metal content in such rocks that can be profitably mined and processed to extract the metal is called the ore of that metal. The other minerals present in ores, which are not of much use, are called gangue. They should be removed as impurities. Some metals are not very reactive, and hence do not combine with other elements naturally. Hence, they occur in a free state in nature. Their ores contain particles of the metal mixed with large quantities of impurities. These metals are known as noble metals. Gold, platinum, silver, etc. are some of the noble metals. Ores of very reactive metals, such as calcium or sodium, contain chlorides or carbonates of metals. Rock salt, NaCl, and dolomite KMgCO3 are examples. Ores of other less reactive metals, such as aluminium, iron, copper or zinc, contain mostly oxides or sulfides. Bauxite, Al2O3 iron pyrites, Fe2, hematite, Fe2O3, copper glans, Co2S, and zinc blende, ZnS, are some examples of such ores. The process is carried out to extract pure metals from their ores is called metallurgy. Occurrence of non-metals and metalloids. Hydrogen. Hydrogen is the most abundant element in the universe. It is the main element which makes up the sun and other stars. On Earth, hydrogen occurs mainly in combined form as a constituent of water. Approximately 11% of mass of water is hydrogen. Petroleum, natural gas, coal, clay, and all plants and animals. Nitrogen. Nitrogen occurs mainly in a free state in the atmosphere. About 78% of mass of air is nitrogen. In combined state, it is a constituent of minerals such as chili saltpeter, NaNO3, and nitre, KNO3. Oxygen. Oxygen is the most abundant element present in the Earth's crust. In the atmosphere, it occurs in free state forming about 21% of mass of the atmosphere. In combined state, it forms about 89% of all water on Earth. It also exists in combined state in the Earth's crust as oxides, carbonates, and metal silicates. Carbon. In free state, carbon occurs as graphite, diamond, and coal. Diamond and graphite are pure forms of carbon. Coal contains 60 to 90% of carbon. In combined state, carbon occurs in atmosphere as carbon dioxide. In the Earth's crust, it occurs as carbonates of metals and as fossil fuels. Carbon is the central element of all living matter. Silicon. Silicon is the second most abundant element in the Earth's crust. It does not occur in the free state. In combined state, it occurs as silica, CO2, and silicates. The most common form of silica is sand. Sulfur. Sulfur exists in free state in the Earth's crust. In combined state, it occurs as metal sulfates and sulfides in rocks. It also occurs in hydrogen sulfide, H2S, that is present in petroleum and natural gas. Noble gases, like helium, neon, argon, krypton, and xenon occur in their elemental, free, form in air. Non-metals help in production of many useful chemicals and products. Physical properties of metals. Malleability. Activity. Take a few iron nails, a piece of coal, metal foil, copper wire, and pencil lead. Clean all with a piece of sandpaper. Observe the appearance of all the samples. See whether they are solid or not. Do they have a shiny appearance? Hammer each object with the same force. Take care that you do not hurt yourself while hammering. Observe if the sample breaks, gets flattened or remains unchanged. Record your observations. Table. Material. Appearance, shiny/dull. Hardness. Changes in shape on hammering, flattens/breaks into pieces. Iron nail. Shiny. Very hard. Flattens. Coal. Dull. Soft. Breaks into pieces. Copper wire. Shiny. Hard. Flattens. Pencil lead. Dull. Soft. Breaks into pieces. Metal foil. Shiny. Hard. Flattens. It will be seen that iron nail, copper wire, and aluminium foil change their shapes on beating. They can be beaten out to form very thin sheets. This property of metals by which they can be beaten into thin sheets is called malleability. Gold, silver, and aluminium are most malleable metals. Non-metals are brittle, so they cannot be beaten into thin sheets of oils. Conductivity. Activity. To check electrical conductivity of metals and non-metals, take a small sample of aluminium wire, copper wire, coal piece, sulfur, and iron nail. Connect a pencil cell and a bulb as shown in the diagram with the help of connecting wires. Connect the two free ends of the copper wire, A and B, to the objects one by one. See if the bulb glows or not. Record your observations. Table. Serial number. Material. Good conductor/poor conductor. 1. Aluminium. Good conductor. 2. Coal piece. Poor conductor. 3. Sulfur. Poor conductor. 4. Iron nail. Good conductor. 5. Copper wire. Good conductor. You will notice that metals like aluminium, iron, and copper are good conductors while non-metals like sulfur and coal are bad conductors of electricity. Metals are therefore used for making electrical cables and wires. Graphite, which is a non-metal, is an exception to the rule that non-metals are poor conductors of electricity. Silver is the best conductor of electricity. Thermal conductivity. Metals are also good conductors of heat and are therefore used for making cooking utensils. However, the handles of such utensils are made of wood or plastic, which is a bad conductor of heat, and thus convenient to hold. Silver is the best conductor of heat, but due to its high cost, it is not used much. Next best conductor is copper. Physical state. Metals are generally solids except mercury and gallium, which exist as liquids at room temperature. Non-metals are usually solids or gases at room temperature. Only bromine exists as liquid at room temperature. Hardness. Most metals are hard, the only exception being sodium and potassium, which can easily be cut with a knife. Non-metals are generally soft, with diamond being an exception. It is the hardest known substance. Ductility. The property of metals by which they can be drawn into wires is called ductility. Non-metals are brittle, so they cannot be drawn into wires. Sonority. The ability of metals to produce ringing sounds is called sonority. You must have heard different sounds when an iron plate or a metal coin is dropped on the floor. Metal objects produce a ringing sound when struck hard. Metals are sonorous. This is the reason objects like wind chimes and bells make a ringing sound. Non-metals are non-sonorous. They produce a dull sound when struck with a hard object. It can thus be concluded that materials which are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity are called metals. Examples are iron, copper, aluminium, gold, silver, etc. In contrast, some materials are soft and dull. They break down into pieces or powder when hammered. They are poor conductors of heat and electricity, and are not sonorous. These materials are called non-metals. Chemical properties of metals and non-metals. Reaction with oxygen. Metals react with oxygen to form their oxides. Different metals react with oxygen under different conditions. Metal plus oxygen O tilde metal oxide. Sodium reacts with oxygen at room temperature to form sodium oxide. Magnesium, on heating, burns in air to form magnesium oxide, MgO. 4 Na plus O2 O tilde 2 Na 2O. 2 Mg plus O2 O tilde 2 MgO. Activity. You have already learnt in the previous class that rust is formed due to reaction between iron, oxygen, and water. Dissolve a teaspoon of rust in water. What do you observe? Rust remains suspended in water. Shake the test tube well. Test whether the solution is acidic or basic with the help of red and blue litmus papers. Suspension rust of rust. Red litmus paper. Rust. The metallic oxides formed are basic in nature and turn red litmus solution blue. Have you seen a greenish deposit on the surface of copper vessels when exposed to air for long? This occurs due to the formation of a mixture of copper hydroxide and copper carbonate, which is green in color. 2Co plus H2O plus CO2 plus O2O tilde CO2 plus CO3. Non-metals. They also react with oxygen to form non-metallic oxides. Non-metal plus oxygen O tilde non-metallic oxide. Activity. Reaction of a non-metal with oxygen. Note, the teacher should demonstrate this activity. Take a little quantity of sulfur in a deflagrating spoon and heat it over the flame of a burner. When sulfur starts burning, lower the spoon into a glass jar or glass tumbler. Cover the mouth of the tumbler with a plate so that the gas produced may not escape. Remove the spoon after some time. Add about 20 milliliters water into the jar and close the cover immediately. Shake well. Test the solution with both red and blue litmus papers. The metallic oxides formed are basic in nature and turn red litmus solution blue. Have you seen a greenish deposit on the surface of copper vessels when exposed to air for long? This occurs due to the formation of a mixture of copper hydroxide and copper carbonate, which is green in color. Non-metals. They also react with oxygen to form non-metallic oxides. Non-metal plus oxygen O tilde non-metallic oxide. Activity. Reaction of a non-metal with oxygen. Note, the teacher should demonstrate this activity. Take a little quantity of sulfur in a deflagrating spoon and heat it over the flame of a burner. When sulfur starts burning, lower the spoon into a glass jar or glass tumbler. Cover the mouth of the tumbler with a plate so that the gas produced may not escape. Remove the spoon after some time. Add about 20 milliliters water into the jar and close the cover immediately. Shake well. Test the solution with both red and blue litmus papers. Sulfur burns in oxygen to form sulfur dioxide. S plus O2 O tilde SO2. When sulfur dioxide is dissolved in water, sulfurous acid is formed which turns blue litmus red. SO2 plus H2O O tilde H2SO3. Generally, oxides of non-metals are acidic in nature. Reaction with water. Metals react with water under different conditions. However, most metals produce a metal hydroxide or metal oxide and hydrogen gas. Metal plus water O tilde metal hydroxide plus hydrogen gas. Or metal plus water O tilde metal oxide plus hydrogen gas. Activity. Carry out this activity strictly under the supervision of an adult. Take a half-filled 250 ml beaker with water. Cut a small piece of sodium about the size of a wheat grain very carefully. After drying it in filter paper, wrap it in cotton. Dip the cotton in the beaker of water. Observe the reaction taking place in the beaker from a distance. When the reaction stops, touch the beaker. Test the solution with both blue and red litmus papers. Observation: sodium will react vigorously with water. The beaker becomes hot. Sodium reacts most vigorously, followed by magnesium, aluminium, zinc, and iron. 2 Na sodium plus 2H2O water. 2 Na sodium hydroxide plus H2 hydrogen. Mg magnesium plus H2O water, hot. Mg magnesium oxide plus H2 hydrogen. 2Al aluminium plus 3H2O water. Al2O3 aluminium oxide plus 3H2 hydrogen. Aluminium reacts with water to form aluminium oxide, which gets deposited as a thin layer on aluminium and prevents further reaction from taking place. Zn zinc plus H2O steam. Zno zinc oxide plus H2 hydrogen. Generally, non-metals do not react with water, though they may be reactive in air. Phosphorus is a very reactive non-metal. It easily catches fire when exposed to air, hence it is stored in water to prevent its contact with atmospheric oxygen. Reaction with dilute acids. Metals react with an acid to form a salt, and hydrogen gas is produced. When a burning matchstick is brought near the mouth of the test tube containing the products of the reaction, a pop sound is produced. This shows the production of hydrogen gas. Non-metals do not produce hydrogen gas, and they do not react with dilute acids. Copper does not react with hydrochloric acid even on heating, but reacts with sulfuric acid. 2 Na sodium plus 2HCl hydrochloric acid. 2 NaCl sodium chloride plus H2 hydrogen. Fe plus 2HCl hydrochloric acid. FeCl2 ferrous chloride plus H2 hydrogen. 2Al aluminium plus 6HCl hydrochloric acid. 2AlCl3 aluminium chloride plus 3H2 hydrogen. Mg magnesium plus H2SO4 sulfuric acid. Mg-SO4 magnesium sulfate plus H2 hydrogen. Reaction with bases. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets in a teaspoon of water. Use a plastic spatula in taking out sodium hydroxide pellets. Drop a small piece of aluminium foil in it. Bring a lighted matchstick near the mouth of the test tube. Observe what happens. You will hear a pop sound due to the presence of hydrogen gas. Only some metals react with strong bases such as sodium hydroxide to produce hydrogen gas. The reaction of non-metals with bases is complex. Displacement reactions. In displacement reactions, a more reactive metal replaces a less reactive metal from its compound. However, vice versa is not possible, i.e. a less reactive metal cannot replace a more reactive metal. The reaction of metals with oxygen, water, and acids shows that metals have different reactivities. Potassium and sodium are the most reactive, while silver and gold are the least reactive. Metals can be arranged in order of their decreasing reactivity in a table. Such an arrangement of metals in decreasing order of reactivity is called the reactivity series of metals. Table. Element. Symbol. Reactivity. Potassium. K. Most reactive. Sodium. Na. Decreasing reactivity. Barium. Ba. Calcium. Ca. Magnesium. Mg. Aluminium. Al. Zinc. Zn. Iron. Fe. Nickel. Ni. Tin. Sn. Lead. Pb. Hydrogen. H. Copper. Cu. Mercury. Hg. Silver. Ag. Gold. O. Least reactive. Reactivity series of metals. A metal can replace another metal placed below it in the reactivity series, but cannot replace a metal above it in the reactivity series. Similarly, the position of hydrogen in the reactivity series shows which metals can displace it from dilute acids. Metals above it in the series will displace it while metals below it in the series will not. Silver and gold are present at the bottom of the reactivity series of metals. They are known as noble metals. They are unreactive metals and do not react with water, acids and alkalis. Activity. Displacement reaction. Take some iron filings in a test tube marked A, add copper sulfate solution to the test tube with the help of a dropper. In another test tube marked B, take some copper turnings. Add iron sulfate solution to it with the help of a dropper. You will notice that in test tube A, iron filings turn brown. This is due to the deposition of copper. The solution turns pale green due to the formation of iron sulfate solution. Test tube A. Test tube B. No change in color. No change occurs in test tube B. Thus, iron being more reactive than copper displaces copper from copper sulfate solution. Since copper is less reactive than iron, it cannot displace iron in iron sulfate solution. Fe plus Q so 4 Fe so 4 plus Q. Iron plus copper sulfate. Q plus Fe so 4 O tilde no reaction. Iron sulfate plus copper. Q plus Fe so 4 O tilde no reaction. Uses of some metals. Iron. Pig iron is a hard and brittle form of iron having a high carbon content. It is used to make pipes, sinks, storage tanks, railings, cylinders, etc. by the process of casting. Wrought iron is a tough malleable form of iron with a very low carbon content. Heated wrought iron is hammered to make nails, bolts, chains, wire nets, agricultural tools, etc. Steel, 0.5 to 1.5% carbon, is used in construction of buildings, ships, bridges, railway lines, etc. Stainless steel is used to make utensils, knives, etc. Copper. Copper is widely used to make electric wires, cables, etc. Copper coils are used in many electrical appliances. It is also used to make car radiators, calorimeters, and heating utensils. It is a major constituent of many useful alloys such as brass, bronze, etc. Aluminium. Aluminium is increasingly being used as an alternative to copper as an electric conductor, especially in overhead cables. It is used to make cooking utensils. Aluminium foil is used for packing food. Aluminium powder is used as paint to prevent rusting of iron. Aluminium alloys are light and strong. They find use in manufacture of engine parts of cars and aircraft. Zinc. Zinc is used in dry cells. It is used in coating iron sheets to prevent rusting of iron. This process is called galvanization of iron. It is used to make useful alloys like brass and German silver. Lead. Lead is used to make electrodes of automobile batteries, alloys for soldering. Tin. Tin-coated steel is used to make food containers. It is also used to make alloys like solder and bronze. Chromium. Chromium electroplating on iron gives a corrosion-proof, shiny finish, i.e. bicycle handles, car bumpers, etc. Nickel. Nickel is used to make alloys, castings on other metals to prevent corrosion. Titanium. Titanium is a light, strong and corrosion-resistant metal. It is used to make aircraft bodies. Mercury. Mercury is liquid at room temperature. It is used in thermometers and barometers. Uses of some common non-metals and metalloids. Silicon. Silicon is widely used in electronic and computer industry to make devices like transistors, microchips, and solar cells. It is used to make silicones that find use in making waterproof clothing, grease, and polish. Silicon is also used as insulating material for electrical appliances. Sulfur. Sulfur is used in the manufacture of sulfuric acid, which is an important industrial chemical. It is used in vulcanization of rubber, making it hard enough to be used in tires. It is used in skin ointments because of its fungicidal properties. It is used to spray fruit trees against pests and diseases because of its properties as a fungicide and insecticide. Phosphorus. Phosphorus is used to make matchboxes and fireworks. It is also used in the manufacture of phosphate fertilizers. Carbon. As graphite, carbon is used to make lead of pencils, dry cell electrodes, electric arcs, in furnaces, and as a dry lubricant. As diamond, it is used in jewelry, and in making cutting tools. As charcoal, it is used in filters to purify air and water. As coal, it is widely used as a fuel. Hydrogen. Hydrogen is used to manufacture ammonia gas, which in turn is used to make fertilizers like urea and ammonium sulfate. It is used in metal extraction, copper, tin, lead. Oxyhydrogen flame is used for cutting/welding metals. Hydrogen may be used as a non-polluting fuel in the future. Rusting of iron. Corrosion is a natural process where materials such as metals chemically deteriorate when exposed to air and moisture. Rusting of iron is a type of corrosion which takes place when iron is exposed to moist air for a long time, which develops a thin coating of iron oxide on its surface. Aluminium also corrodes when exposed to moisture to form a layer of aluminium oxide on its surface. This layer protects aluminum from further corrosion. Copper gets corroded in presence of carbon dioxide and water. A green coating forms on its surface, which is a mixture of copper hydroxide and copper carbonate. 2Co plus H2O plus CO2 plus O2O tilde CO2 plus CuCO3. Silver forms a black coating of silver sulfide on reaction with air containing hydrogen sulfide. Metals such as gold and platinum do not corrode in air. They do not lose their shine even after several years. Ways to prevent corrosion. Some of the methods by which we can prevent rusting of iron and corrosion of metals are as follows. Painting or applying oil or grease to the metal prevents its corrosion. Iron sheets are prevented from corrosion by dipping them in molten zinc to deposit a layer of zinc on them. This process is called galvanization. Tin is electroplated on iron to make food containers or tin cans. Chromium is electroplated on steel furniture and bicycle handles to prevent rusting. Anodizing of aluminium deposits a uniform protective layer of aluminium oxide on the metal. This cuts off its exposure to oxygen and prevents its corrosion. Alloying also helps in protecting metals against corrosion. Stainless steel is an alloy of iron, chromium and nickel, and does not rust easily. Alloys. An alloy is a substance made of two or more metals or one or more metals and a non-metal. It has better characteristics than the pure metals in the matter of strength or hardness. Alloying is used to increase the hardness of metals. Alloying is used to make metals more resistant to impact of chemicals and atmospheric corrosion. Alloying is used to change the properties of metals in other beneficial ways. Some important alloys. Table. Alloys. Composition. Uses of the alloy. Brass, copper, zinc. Utensils, electrical goods, musical instruments, etc. Bronze, copper,